What I'm gonna show you today has been ranked as the top web security vulnerability for a decade, with consistent presence at the OWASP top 10 for 21 years. Hey and welcome to Security Bytes, a series of short videos from the GitHub Security Lab aiming towards educating developers on common software bugs. Today we are going to look at a critical but quite common injection bug for JavaScript called cross-site scripting, or XSS. A hacker who exploits a cross-site scripting vulnerability is able to first, deface a website, which means to change how it normally looks. Second, impersonate the victim by carrying out actions with their privileges. And finally, hijack the victim's session after capturing session cookies or authentication credentials. If the user is locked in a vulnerable application, then the attacker might be able to gain full control over all of the application's functionality and data. XSS works by manipulating a vulnerable website so that it returns malicious JavaScript to users when rendered on the victim's browser. The attack vectors for XSS are diverse, but what they all have in common is that they occur due to improperly handled input. Specifically, when websites render data that is controlled by an attacker without proper sanitization, causing browsers to execute malicious JavaScript. The malicious input can be passed in various ways, including the get or post parameters, or the info contained in HTTP requests, such as cookies and HTTP headers. The attack surface can range from a single to multiple injection points, with attacks being direct or indirect. Finally, some attacks are triggered automatically, while others require certain interactions. When the code to be displayed to the user is dynamically built without security in mind, there exist certain characters that can facilitate the XSS vulnerability to occur. These include the double quotes, single quotes, and angle brackets. If a site properly sanitizes characters, then they render as HTML entities. For example, the page source for a website will show these characters as on screen. This is because these special characters, when unsanitized, define a website's structure in HTML and JavaScript. For example, if a site doesn't sanitize angle brackets, an attacker could insert some malicious code in between the script tags to inject the payload. Notice that attackers don't really need opportunities to insert a script tag in order to harm. They can cause severe problems with just single or double quotes. For example, consider a website that unintentionally provides the opportunity to access the following snippet's value attribute. By injecting a double quote in the value attribute, hackers could close the existing quote and inject malicious JavaScript. They might do this by changing the value attribute to attacker double quotes on focus equals alert document cookie, with the intention to eventually steal the session cookies of every visitor that visits the website towards hijacking their sessions. I'm saying eventually here because a few more lines are needed to steal cookies successfully, but in general it is considered quick and easy. Therefore, you should watch out. The result code could result in the following. The onFocus attribute tells the browser to execute JavaScript when the user clicks the text box, which will trigger the payload. There are two main types of XSS, reflected and stored. The reflected occurs when a single HTTP request that isn't stored anywhere on the site delivers and executes the XSS payload. Despite browser developers' prevention efforts, defenses are frequently bypassed because JavaScript can execute in various and complex ways on a site. In contrast, stored XSS occurs when a site saves a malicious payload and renders it unsanitized. The payload can be stored on the target server, such as in a database. Sites might also render the stored payload both from and in various locations. The payload might not execute immediately after submission, but it could execute when another page is accessed. For example, if you create a profile on a website with an XSS payload as your name, the XSS might not execute when you view your profile. Instead, it might execute when someone searches for your name or sends you a message. You can also classify XSS attacks into the following three subcategories: DOM-based, blind, and self. Let's explain the most impactful, starting from DOM-based, which is about manipulating a website's existing JavaScript code to make it malicious, either as stored or reflected XSS. For example, consider this site that trusts the user-supplied URL to replace some elements in the following code. In this example, the name field is retrieved from the URL using id equals name. Then, by using the hash, JavaScript will scroll to the point at the website that the text after the hash points to. But since this page completely trusts user-supplied URLs and doesn't sanitize before updating the span element, a malicious user or even an unsuspecting user who clicked it could provide the following URL instead that will result in this HTML code. When the page loads, malicious JavaScript executes. It's common for attackers to initiate attacks using the onError method as indicated above. The method will trigger malicious code execution immediately when the browser will not be in position to render an image called X, which we assume is the case above. Blind XSS is a stored XSS attack in which another user renders the XSS payload from a location of the website a hacker can't access. For example, this might happen if you could add XSS as your first and last name when you create a personal profile on a site. Those values can be escaped when regular users view your profile. But for example, when an admin visits the administrative page listing all new users on the site, the values might not be sanitized and the XSS might execute. Let's now see a real-world example uncovered from the GitHub Security Lab researchers. First, in the emoji button software, our researcher Agustin Gianni reported that an attacker able to influence the field emoji will be in position to supply arbitrary HTML or JavaScript that will be rendered in the context of a user, leading to XSS. Another case is this one, where our researcher Alvaro Munoz, or Pontester, uncovered the case of stored XSS. An attacker with elevated privileges could create content selectors with specially crafted names so that when viewed by another user, the malicious XSS will be executed. The impact is that the attacker could forge requests on behalf of the user. This action will redirect the user to another site or modify the page content, and the suggested remediation will be to escape content selector names when rendered by the front end. Preventing cross-site scripting depends on the complexity of the application and the ways it handles user-supplied data. In general, prevention is likely to involve the following. First, input sanitization on arrival following the deny-all approach as explained in previous episodes. Second, encode data on output to prevent it from being interpreted as active content. Encoding is not only about HTML, but also for JavaScript, CSS, and URLs. Third, use appropriate response headers. To prevent XSS in HTTP responses that aren't intended to contain any HTML or JavaScript, you can use the headers, content type, and X-content type options to ensure that browsers interpret the responses in the way you intend. Finally, enable Content Security Policy, or CSP, which is a browser security mechanism that aims to mitigate XSS by restricting the resources, such as scripts and images, that a page can load alongside privilege control, such as whether a page can be framed by other pages. Make sure to leave a comment below to let us know which vulnerabilities to cover next. In the meantime, stay in the loop by following us on Twitter. Remember, Quality Code is a QR code.